Hi, we're now going to do the test case that was described here, the straight coast with a somewhat long wave model and a shorter flow model that is smaller to avoid the boundary disturbances in the wave model, with a grid resolution of 20 by 50 meters and bottom slope from 10-meter depth to -1 meter depth, and with waves as given here. Now let's see, how are we going to do that? Just so we'll show the desktop. Okay, I start Delft 3D. No, sorry, wrong Delft 3D. This one. Delft 3D. Oh, where's my Delft 3D? Okay, here's my main menu of Delft 3D. And the first thing, of course, select a working directory. And we're here in Coast 2020. Select this folder. So I'm there. Now I'm going to create a grid with RGF grid. And we're going to use the option of create a rectangular or circular grid. And it had to be 1 kilometer and with a resolution of 20 meters in one direction. So the 50 cells of 20 meters each. And in the other direction, we want 4 kilometers of 50 meters. So that is 80 cells of 50 meters. That is 4,000 meters. And then we'll have this model set up. So this is our wave model. Okay. Let me see if I did everything okay. Operations, create rectangular. I still have all my things there. I just want to make sure I don't have any zero values in my grid. So I'm going to put it at 1, 1. Okay. And this will be my grid. So I'm going to save this grid, export grid as the wave grid. Now the next thing I'm going to do is to create the flow grid. And let's assume that I put it just in the middle of the wave grid. Operations, create rectangular, etc. So now I'm going to just have 40 cells in the Y direction, and I'm going to shift the origin by 2 kilometers. So is that correct? 4 kilometers, the other one was 2. No, I should shift it by 1 kilometer. Yes. So, okay. So this is now my flow grid. You see it's pretty small. File, export, grid. I call it flow. And let's see, I think I can import you see the view previous. That's not a good idea. Anyway, I've created that the both grids now. I would like to show them both in one. I forgot how to do that. Import grid. Yeah, now I see. So I see that both grids match very nicely, and it's just that the flow model is smaller than the wave model. Okay, to avoid these boundary effects. So that's done. Now I go and specify the depth on it. I go to Quicken, and first I will import the grid of the wave grid, because that's the biggest one. And now what we can do is first I'm going to set the depth at the corner points here to 10 meters and -1. And then I'm going to interpolate between those, and then I'm going to sweep that to the whole grid. So how do I do that? Edit depth. If you go that, and you can zoom in and out with your mouse roller. So I click this one and I just say this is 10 meters. Okay. Now I don't see anything. Why don't I see anything? It's because I should set view depth to colored dots. And then you see this little colored dot appear. And now I'm going to set this one, and I'm going to set that to -1. Okay. So now I've got two values here, and I can interpolate between those. How do we do that? Edit depth linear. And then you click one point, and you click the other point, and there you see a nice shifting depth. And then I'm going to go edit depth line sweep, and then I do tuck, tuck, and there I got the same profile on the whole grid. Now, to make sure that I'm going to, well, I think I will just repeat this procedure for the flow model as well. So I say File, Export Depth, and I call this wave.depth. Then I go out of Quicken and in again, because it doesn't like if I then load a different grid, it gets confused. So import grid, I just repeat everything for the flow grid. So what did I do? Edit depth. I go here and I say 10. And again, I do view depth color dots. I do depth here, -1. Okay. Edit depth linear. Tuck. Stuck. And then I do edit depth line sweep from here to there. So I got identical depths now in the flow and the wave map. So export depth. And I call this flow.depth. Okay. Okay. We're done with the input of the grids, etc. So now we're going back to the main menu and we go to the hydrodynamics, where we have to define both the flow and the wave model. Well, let's start with flow. We've seen that before. So description, post model, the domain, we open a grid, the flow grid. We open a grid enclosure, flow enclosure. We define the bathymetry from file, open, flow depth. The domain time step maybe will take a bit smaller time step now. Let's do 0.2 minutes. The processes, that's important here. So now we're going to first put the wave in. And the wave tells us we need to do something in the output to define the communication file. So we go to the output, and in the communication, we now have to say that it has to run from the 23rd till the 25th, an interval, let's say 20 minutes. Let's put the map results also at 20 minutes and the history interval at 1 minute. And no restart, 0. And now we say, okay, go back to processes. We have online Delft 3D wave. So it's automatically coupled. We'll see how easy that is. Initial conditions are 0. Boundaries, we do have to define the boundaries as we did before. And now we'll have these Neumann boundaries at the top and the bottom and a water level boundary at the seaward end. So we do edit, open boundaries, edit mode, add. We add that boundary, the north boundary, and the south boundary, and the sea boundary. Let's see where we got here. So we rename those. So we say this is north, and this is south, and this is sea. North, we make it Neumann with time series boundary, or harmonic boundary is fine too. Edit flow condition, everything, all the amplitudes to 0. Okay, close. Same for the south boundary. Neumann, harmonic, everything set to 0. And the C, that is a water level boundary, also harmonic, and also all zeros. So we have 0 water level, and we have 0 gradients in the water level. So everything will be determined by the wave forcing. We save the boundary definitions. And this is ghost. And we save the harmonic flow conditions. Ghost. Close this. And we do save MDF. We call that ghost as well. Now, physical parameters. We now have something called, in roughness, we have a stress formulation due to wave forces by Fretzer, and viscosity, we don't touch that. Numerical parameters, we keep everything standard. We don't have any operations. We add some monitoring points here, edit observation points, edit mode, add, and we just click a few ones. So we have an idea of how it is behaving in the time domain. Ghost. Additional parameters. Here's one that is important. That is a magic word, CST, B, and D. And that has to be yes. And this creates nice, smooth boundary conditions for the case of a small coastal model. The output is we already set that, so we're all set for the flow model. File, save MDF, and we're done for the flow model. Now we go to the wave model. So description again is the ghost model. Hydrodynamics, we only say we run wave together with flow, and there we have to set the flow MDF file. And that's all we need to do. And then in the output parameters already has set that output for flow grid. So grids, we need to import a computational grid, and that's the wave grid. And we only have one grid, the bathymetry is based on a computational grid, and the bathymetry data is this. So here we've defined our computational grid and bathymetry. Spectral resolution we leave at default values. There's no nesting because it's only one wave grid. The hydrodynamics, so here, yes, okay. So these things, they tell us that because our wave model is bigger than the flow model, that if something happens inside the flow model and we use the water level, then it only gives us information on the domain of the flow model, which is smaller. So we ask it to extend it, to extrapolate to the whole wave input grid. Obstacles, we'll get to that later. Physical parameters, there's some constants to set. Well, we do this, we use these default values. There's no wind at this moment. We don't use the nonlinear triad interactions. We do have bottom friction, and there's a bit more white capping. We should turn it off if there's no wind. And we can also turn the frequency shift off, well, or we can leave it on. Yes, that is mostly active if we have wave current interaction, and we included that. So then we have to define the numerical parameters. Well, we'll keep those at default values. We go to output parameters. We do write and use hot start file so that every next time we run the wave model, it uses the previous results to hot start on, and that makes everything much faster. We also want output for the computational grid, and we can have all sorts of table output, but I'm not interested in that at the moment. And here we could add additional parameters that are recognized by Swan, but we don't do that at the moment. So we'll just say file, save, and then we called it ghost.mdw. The boundaries, we haven't said anything. We need to add a boundary. And that is going to be west, and is also defined as a west boundary. Uniform boundaries, we edit the conditions, and was going to be 2 meters, 7 seconds, 240 degrees, and with a directional spreading of 4. And I'm going to do the same boundaries on the north and the south side. Well, definitely on the south side. In fact, I don't need the north one because my waves are propagating towards the north. So I edit the conditions there. I put the same conditions there, 2 meter, 7 seconds, 240. Okay. And I save my MDW file. And now I should be set to start the model. And here it's first asking me for the MDF file. Okay. And now it's asking me for my MDW file, the master definition for the waves. Don't be confused by this thing. Just say okay. And now it's starting both. There we go. Well, it's very exciting. In the meantime, we can start QuickPlot and see if everything's going well. So in QuickPlot, we have these files now. So WAVM, that's the wave output file. So let's see, what do we have? The wave height. That looks sort of okay. But you see there's a disturbance here, and it's not a huge disturbance because we also put the boundary conditions here. They're too high, but that has a limited effect. But at 1 kilometer where the flow model starts, we should be okay. So if we look at the flow model, well, the communication file is interesting. There you see everything that's communicated. So the same thing, the wave height, and you see it's nice and uniform in this area. And we also see the wave force, for instance, as a vector. So these are very nice, uniform wave forces. If you zoom in, you'll see that they have a strong component towards the coast that drives the setup, but they also have a small component along shore that drives the longshore current. We also have the current velocity on the communication file because that's used by the wave model. And you see again, it's very nice and uniform along shore. We can also look at on the WAVM file, there should also be a current. Where is the current velocity? And you see that also the current velocity is defined on the whole wave grid, even though the flow model only runs from 1000 to 3000. So this extrapolation is working perfectly well. And that's why you don't have any disturbances at the boundaries of the flow model. So it looks like everything is going nice and smoothly. And then of course also the trim file that has the information of that of course should also have a decent depth average velocity. That's of course the same as on the communication file and everything. And we can well, you see that very quickly after the flow has gone back and forth a bit between the current and the wave model, it really stabilizes. Now, why did I let it run so interactively and for 2 days? That is because next we're going to turn it into a morphological model, and then of course the bottom is going to change, and it's going to change both for the flow and for the waves because we use the updated bottom from the flow model in the wave model. But so far so good. We've got a working wave current interaction model for a very simple straight coastline.